Okay guys, the purpose of this video is just to go over the work that you're supposed to do for today, September, I believe the 14th, sorry, September 15th, my bad. And the title of your assignment was to do, how can you estimate products? And you were supposed to do problems 1 through 22 on pages 101 through 102. So here we go, let's go ahead and get started. There are two ways in which you can estimate here, or you can round off numbers, or at least try and see if you can find an estimated sum. You can either do rounding like we talked about earlier, or you can actually find compatible numbers. We're going to try and do it as easy as we can using both methods, or at least trying to use the best method to multiply these numbers. So let's go ahead and get started. And number one, you got 29 times 688. The best way to just simply multiply that is by simply just rounding 29 to 30, because 29 is closer to 30. And then of course multiply that by 688. Since 8 is close, gets that 6 closer to 7, we multiply by 700. And of course, if you know how to use the trick real quick, you can simply just count the number of zeros that you have in both of your numbers, and then of course put it down at the bottom. So in 700 I've got 2 zeros, so I'm going to put 2 zeros down. And in the number 30 I've got 1 zero, so I put that 1 zero, and then I multiply what's left over. 7 times 3 is 21. So the product is 21,000. And remember that in the lesson we talked about how the number 700 and the number 30 are what we would call the factors, right? These two would be called factors. And then, of course, the answer in multiplication is what we call the product. And sometimes it's also even called the multiple. Okay, so we're going to use those terms a lot during class time, all right? So let me go ahead and I'm going to do it the old way now. Follow the process. 700 times 30. Multiply by 0. 0 times 0 is 0. 0 times 0 is 0. 0 times 7 is 0. Get your second partial product. 3 times 0 is 0 in the tens place. If you want to put a 0 in the ones place, then go for it. And then 3 times 0, 0 again. And 3 times 7 is 21. Add your two products, partial products. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. Bring down the 1 and the 2. And you see, we end up still getting the same product or multiple, which is 21,000. Now let's play with the vocabulary words before we go on to the next problem. We say that 30 is a factor of 21,000, or we can also say that 700 is a factor of 21,000, or we can say backwards. We can say that 21,000 is a product of 30, or we can also say that 21,000 is a product of 700. Okay, let's move on to number two. Number two, we've got 733 times 21. And of course, we're going to round off each number to highest place value. Because of the 3, that 7 stays the same. And because of that 1, that 2 stays the same. So we've got 700 times 20. Notice that in this case, both estimates are less than the actual number. So we can say that whatever product we get down here is going to be an underestimate, okay? And that's what the instructors are kind of telling you to do. You're supposed to tell if the estimate is going to be an overestimate or an underestimate. And in the first one, let me go back. Since we rounded off 29 to 30 and 688 to 700, since both estimates are greater than the actual numbers, it's obvious to say that our estimation is going to be overestimated. But in number two, since our estimates are less than our actual numbers, we say that our estimate will be underestimated. So again, the trick is get the number of zeros that you got in both numbers, and we got 3. And we multiply 2 times 7, which is 14. So there's your product, 14,000. And it's an underestimation. All right. Let me go on to number 3. Number 3, you got 43 times 108, piece of cake. Simply just a round off 108 to 100 because of that 0. And round that 43 to a 40 because of that 3. Get your zeros, your extra zeros. 1, 2, 3. 1, 2, 3. Multiply what's left over. 4 times 1, which is 4. So there's your product or multiple. Remember, the products are, there's only one product, right? 4,000. And then your factors are 140. We say that 100 is a factor of 4,000. We can also say 40 is a factor of 4,000. Or we can go backwards and we can say 4,000 is a product of 40. Or 4,000 is a product of 100. Okay, now let's move on. to number 4. Number 4, we've got 690 times 38. Now, the question again is, why in the world do we estimate, right? Well, remember that estimation helps us to get to as close as possible to the actual number, right? If our actual product ends up being way greater than our estimation, that's a clue or red flag that tells us that we're doing something wrong, right? So estimation helps us to, at least try and come up with to as close as possible to the actual product or answer. So 690, we round it off to 700 because of that 9 in the 10th place. And 38, we're going to round it off to 40 because of that 8. Multiply, put your extra zeros down. And then, of course, 7 times 4 is 28,000. So that means that our actual number has to be somewhere around 28,000. Now, the question is this an overestimation or an underestimation? Well, 690 was rounded off to 700, which is greater. And 38 was rounded off to 40, which is greater. So we say that 28,000 is a overestimate, which means that our actual product here has to be less than 28,000, or somewhere around close to 28,000, but less than it. All right. So now let's move on to number 5. Number 5 is 248 times 82. And of course, we round here because of that 4. This goes to 200. And because of this 2, that 8 goes to 80. Now remember, we're rounding both numbers to the highest place value of each number. In 248, the highest place value is the hundredth. And in the number 82, the highest place value is the tenth. And of course, everything else is easy. Just bring down your extra zeros. 1, 2, 3 zeros. And then 8 times 2 is 16. So your product is 16,000. Is this underestimated or overestimated? Well, 248 went down to 200 when we rounded it off, and 82 went down to 80. So this has to be an underestimate, which means that our product is going to be actually greater than 16,000. All right, let's move on. We're going to continue. Number 6 says, it says estimation. Each egg carton holds 1,000 eggs. Michael's chicken farm fills 121 egg cartons. He thinks that there were over 1,500 eggs. Is he correct? Use an estimate to find out. Well, the question here is, how many eggs do you put in a carton, right? And it says that it's 1,000, so that tells us that that's about 12. So we have a total of 12 eggs in each carton. How many cartons do you have? 121. So there's one carton with 12 eggs, another carton with 12 eggs, another carton with 12 eggs, until you go to 121 cartons. This tells me that I'm going to be using groups and the number in each group, which tells me that I'm going to have to multiply 121 times 12. Remember that it did say, though, that it wanted an estimate, right? And then it wants to for us to check if the actual answer that he came up with, 1,500 eggs in those 121 cartons, is close to the estimation that we come up with. So 121, we're going to round it off to 100 because of that 2. And that 12, we're going to round it off to 1. To 10 because of that 2. So get your extra zeros. 1, 2, 3 zeros. 1, 2, 3 zeros. And then multiply what's left over. 1 times 1, 1. So there is your estimation. Your estimation is that it tells us that you're going to have about 1,000 eggs, right? So, and then of course, his estimation is 1,500. That's a little bit too much compared to our estimation of about 1,000 eggs. That's a big difference. And another thing, let's see if we were to actually multiply 121 times 12, we would actually get this amount, 1,440. So that, that estimation is a little off. Okay, let's move on. Let's try number 7. We're just gonna try a couple more, and I'll let you do the rest. Number 7, we've got 18 times 786. And put them up. Times 18. So what do we do here? Easy. Because of that 8, we're gonna round this off to 600. Because of that 8, we're going to round this off to 2. So we've got 600 times 20. Put your extra 3 zeros down and multiply 2 times 6, which is 12. And there's your estimation. Is it an underestimation or an overestimation? Now, it looks like both of our estimates are greater than the actual numbers, right? You see that? Okay, so we could put in a symbol there to compare them. We could say that 786 is less than that and 18 is less than that. So that means that our estimated product, which is 12,000, is going to be greater than our actual answer. All right. Okay, let's move on to, I'm just going to go to number 14 now. We've got 42,000 times 598. I'm already estimating. So it's easy again. We look at, let's go ahead and stand it up, times 42. And of course, because of that 9, that 5 goes up to 600. And because of that 2, that 4 stays the same. Multiply, we got 3 extra zeros, 1, 2, 3 zeros, 1, 2, 3 zeros, and multiply 4 times 6, which is 24. So our estimation ends up being 24,000. Okay. If you have any other questions, I'm going to introduce to you a real neat math app that you can download through Play Store. It's called Photomath. And Photomath is pretty cool because Photomath actually shows you the steps on how to do the math. I'll teach you that in class. Hopefully I already did that. All right. But if not, just go ahead and, load it up to your phone and check it out. Yeah. I'll show you how to scan. Hopefully if I have enough time right now to show you. So let's move on. Number 7, again, it says estimate 53 times 375. Is the estimate product closer to 15,000 or 20,000? Well, let's just look at that problem. We got 3, so that stays to 50. And then this 7 tells me to move that 3 to 400. So you guessed it, right? You got your 3 zeros on the side, and 4 times 5 is 20,000. So our product is closer to 20,000. Okay, let's go on to number 6. Number 6 says give 2 factors whose estimated product is 8,000. Well, the question is here, what could you multiply? What 2 numbers can you multiply times each other to get that 8? Well, it's easy because you know that 2 times 4 gives you 8. So now all you have to do is remember that in your product, you have to have 3 zeros. So let's just play around with it. We could say that 20 times 400 would give me 8,000, right? Or we could add the 2 extra zeros to 200 and multiply that times 4 with 1 zero. That's 8,000 also, right? So either way, I mean, as long as you have 3 zeros in both of the factors, in both of the factors, which is 20 and 400 or 240, that it'll work. Now, what actual numbers could you use? Well, what number could be rounded up to 20? 19. What number could be rounded up to 400? Well, 398. And these would give me an estimated product of 8,000 when I round them. And those of you that don't get it, well, let's just say because of that 9, that 1 goes to a 2. And then because of that 9, that 3 goes up to a 4. So there it is. You got your 2 factors, 20 times 400. And that for sure is going to give you a product or multiple of 8,000. All right. Let's go on to number 17. It says Samuel needs to estimate the product of 23 times 395. Explain 2 different methods Samuel can use to estimate. Well, we could just simply estimate, round the numbers. We can round off 23 to 20 because of that 3, and we can round off 395 times 400 because of that 9, right? That would give you 8,000. Or we could actually, we haven't used the compatible numbers yet, but we could say, you know what, 23 is close to 25, and that reminds me of a quarter, 25 cents. And then, of course, I could also multiply that times 400. And that would give me a product of 10,000. So either way, you got the estimation and then you got your compatible number right down there, right? 10,000. So those are just 2 different methods of finding an estimate that Samuel can use. Okay, let's move on to number 18. Number 18 It says Lance has 102 packages of sports cards. Each packet has 28 cards, and we can tell again these keywords right here. Packages tell me that this is the number of groups, and 28 cards helps me to understand that that's the number in each group. So whenever I have the number of groups and I have a amount, a set amount in each group, I know that that is multiplication. Okay, and so on and so forth for 102 packages, right? So it says use rounding to estimate. About how many cards does Lance have? About tells me to estimate, round, right? So I'm going to round off 28 to 30, and I'm going to round off 102 to 100. And that gives me a estimated product of about 3,000. Remember, you got 3 zeros, 2 on the 100 and 1 on the 30, so just combine them and then multiply 3 times 1, which gives you 3,000. So the answer ends up being letter C for that one. Let's go on to number. Let me go ahead and get rid of that, please. First, number 19. A company bought 29 computers for 912 each. Again, multiplication. You got the computers, which is the number of groups. You got 29 of those, and remember that each one costs 912. So that's one computer. Here's another computer with that is $912. Here's another computer that's $912, and another computer that's $912. And of course, you do that until you get all the way to 29 computers, right? They want an estimate. That's the deal. So because of that 9, that 29 goes up to 30, and because of that 1, that 9 stays at the same 900. Get your 3 extra zeros, 1, 2, 3, and multiply 9 times 3, which gives you 27. So how much do those 29 computers cost? Well, they're kind of going to cost about $27,000. Now, let's go a little bit above and beyond. Is that an overestimate or an underestimate? Well, 29 went up by 30, and then 912 went down by 900. So that's, again, this one went up and this one went down. So I'd say that since we actually went down by 12 when we estimated 912 to 900, I'd say that this is an overestimate. Okay. Even though, it's an underestimate. My bad, because 912 went down all the way down to 900, which is about a difference of 12. 29 only went up by 1. So you see, we'd say that our product or estimated product of 27,000 is actually an underestimate. All right, let's go on to 20. Number 20 says explain why using either compatible numbers or rounding as a method for estimation would be the same for 32 times 692. I'm just going to give it to you. Either way, I mean, you can try and round them. You're still going to end up with 32 rounded to 30. And then 695, you're going to end up running that off to 700. Now, that would be rounding, right? Now, of course, compatible numbers also works pretty good because, I mean, it's easy to multiply 3 times 7. I mean, 3 times 7 is 21. So, I mean, either way, just simply saying that 32 is closer to 30 and 695 is 700. Or say, you know what, the 3 and 30 would help me to multiply it easier with what other number? With me would be 7 because it gives you a 21. All right, so either way, I mean, it's kind of an easy way to do it for both methods, estimate and compatibility. 21, it says Susan used rounding to estimate 24 times 413 and found 20 times 400. Jeremy used compatible numbers and found 25 times 400. The actual product is 9,912. Whose method gives an estimate closer to the actual product? Well, the estimate that Susan came when you multiply 20 times 400, that gives you 8,000, right? And then if you use the compatible numbers, 400 times 25, that gives you a product of about 10,000. So which one's closer to the actual 9,912? Well, it's the compatible one, 10,000, right? As opposed to 8,000, which is your estimate. So, I mean, the question again, comes up. It's like, which one's better to, come up with an estimated answer? Do we want to use the rounding estimate way, 400 times 20? Or do we want to use a compatible number where we multiply 400 times 25? Because it's easier to multiply by 25, right? Again, it's up to you. And let me go back again to that compatible part. Here, you would put those two extra zeros at the bottom, right? You got two zeros under 400, so you would put them down. And then you would multiply 4 times 25. Well, what's the value of 4 quarters? If you want to think about it that way. Well, that's about 100 cents, right? So that's what you write. You write 100. And you see it ends up being the same, 10,000. So that's why they say it's compatible, because it's easy to get 4 quarters or 4 times 25 and know that it's 100, and then just put those extra zeros to the side, right? Okay, so again, it just depends. Are you the type that thinks estimating is easier to come up with an estimated answer, or are you the type of person that can think of numbers and can make connections between numbers easily? And if you're that type, we'd say that you look for compatible numbers, or you're more of a number sense type of person, right? So it's up to you. Let's go on to 22. It says Abby counts 12 large boxes and 18 small boxes of pencils in a supply cabinet. Each large box has 144 pencils and each small box contains 24 pencils. Estimate the total number of pencils. Is your estimate an overestimate or an underestimate? Explain why it might be better to have an underestimate rather than an overestimate. Well, this one is it's just you require several steps, right? First, they want us to get the estimated total pencils, total number. So that tells me I got to multiply. And then they want me to say if that total is an overestimate or an underestimate. Well, let's figure it out. First, here are the large boxes, right? And they have how many pencils in each? 144, right? And that's a total of 12 large boxes, LB for large boxes. And then, of course, we got the smaller boxes, and each small box has, 24? And that's 18 of those, 18 small boxes. So first, I got to multiply 144 times 12 to get my actual answer. And then to get the total number of pencils in my small boxes, I would multiply 24 times 18. Well, the key here is that we got to estimate, right? So 144, I rounded off to, you guessed it, to 100 because of that 4, right? And 12, you would round it off to 10 because of that 2. Multiply, put your 3 zeros down, and multiply 1 times 1, which is 1,000. So my total number of numbers, or estimated number of pencils in my large boxes, is about 1,000, right? Now let me look at the estimated number for my pencils in my small boxes. Well, 24, like you guessed it before, you can say, okay, I am going to estimate 24 to 20. And if you were to use compatible numbers, instead of using 24, you'd say, it's easier to multiply by 25 by thinking of quarters, right? It's up to you again. But in this probably wants an estimate, so we're going to use estimation. And because of that 8, in that other factor, we're going to round off that 1 to a 2. So therefore, we're 20. And what's 20 times 20? Well, we got 2 extra zeros, 1 here, 1 here. Write them down. And then multiply what's left over, 2 times 2, which is 4. And now the only thing you have left over to do is to add your two products, right? And in this case, let me double check my math just to be on the safe side. We got 104 pencils in the large boxes. So that sounds about right to me. So all you have to do between those two estimated numbers is add them, which is 1,000 plus 400, which gives you an estimated answer of about 1,400 pencils in both the large boxes and the small boxes. Okay. All right. I hope that helped, guys. Just make sure you take the time to review them. Bye.